Hello everyone, this is gonna be a tutorial how to run Rietveld Refinement for evaluating your XRD pattern. We are gonna start from the very beginning. That means I will introduce you the software which is required for running the refinement, how to convert your raw data into a for the software suitable file, how to perform the refinement itself. And for that, I decided to show you two different scenarios, one with an amorphous phase and one with a crystalline phase, because the refinement it's not equal for both of them. And this is something you should be aware of and definitely should know about the fact. And in the very end, I also show you how easy it is to plot the data which will be directly suitable for your reports, for your thesis, or for any kind of publications. Therefore, I would say let's hop in. After measuring your XRD, the device will offer you a raw data file, a text file. Any file is actually fine because we gonna convert it for the foolproof software. In my case here, we have a text file. The text file we convert first into a so-called XY file. And this is easily done by just open the file and save it on other file format by adding .xy. And now it should appear in the folder too, which is the case. So what's the reason for converting it into XY file? The reason is actually the first software we are gonna use, which is called Powdle. And Powdle is not able to convert a text file into a suitable file for the refinement. So you can select here a lot of files, but a text file is not available. That's why we select now XY. And of course, we have to go to the right folder and select the file which we want to convert. Before conversion, we have to select corresponding file format, and we need a .dat file, which is actually obvious because it starts with RIT Y7. I have no clue, but RIT obviously stands for refinement. And I usually give it just a name which the operator himself or herself choose. So, and now we are ready to convert it. And conversion was successful. That's nice. And this is actually already everything which we have to do at the moment with Powdle. Because the next step's gonna be to find a so-called crystallographic information file, a short CIF, and how should we do that? And what is actually a CIF file? And CIF file is actually a file which has all the information of the material which we are evaluating. Long story short, how to find it? The easiest way is to Google it. However, as you can see here, this is not the same material because not every database has the file with the material which you are looking for. Anyways, I would like to show you the database called Materials Project because the web page itself is pretty nice. And you directly see all the parameters which are also involved in the CIF file. And if you want to get the CIF file, you can download it here for free. And I recommend the conversional standard because it's suitable for every software. One nice feature, and this is exactly one reason why I wanted to show here this database, they even provide an X-ray diffraction pattern. And in addition, you can even choose the X-ray source. So like copper, silver, molybdenum, or iron. And important is to see and to understand that the energy of the X-ray source is changing also the reflection. I hope you see the difference. Just have a short look or just realize that they are not equal. And this is something we should consider And we have also to mention this to the software because the software will directly run the calculation based on the X-ray source. Okay, nice database, but not suitable for us at the moment. The alternative is the so-called crystallographic open database, short COD. And here I selected directly the search option, which is pretty good. So you have a lot of options how to find your ZIP file. Another option is, let me go twice back or even three times. Yeah, is the so-called ICSD database, which is from Karlsruhe in Germany. And we just go on the main page, and you don't need to log in, so you don't need to create an account. You just go to the ICSD depot and click on access, and then we will return to the page where you can looking for or search for your zip file. And as you can see here, I was busy the last few days with refinements. My recommendation actually, because as you can see here, you have just a random number, is to ask AI. And if AI can provide you the corresponding number for looking for at COD or here at the Karlsruhe database. Another alternative, and this is something I really appreciate, this is amazing, and I recommend this to everyone, is if there is a publication about the same material or an equal material. As you can see here, they made like a doping. They also provide the crystallographic database or data, sorry, in their supporting information. And this is like heaven for everyone who is running a Rietveld refinement. So in total, I showed you that there are four options. The fifth option is if there is no zip file, then you have to generate it yourself. If you are lucky, then there is some information mentioned in any publications. Otherwise, you have to make theoretical calculations to figure out all the lattice and atom parameters. But this is really something for advanced users of foolproof, and this is not the main reason why I started this tutorial. Okay, and actually we're gonna start and refine our material with this data. I downloaded already. You've been already able to see it in the folder. Talking about the folder, I recommend, and actually this is also necessary, you should keep all the files for one refinement in one folder, especially the PCR file and the DAT file. The PCR file we're gonna create right now because they are directly connected to each other. If they are not in the same folder, the software will show an error. But yeah, let's create an PCR file, and the PCR file is the protocol file which we will use from now on all the time. And this is already the point where we open up the Foolproof Suite software, and this bar is appearing. And here we select the Add PCR, and this window shows up. And here we are looking for this green arrow, not the right one, the first one, called Load ZIP file, which we actually do right now. This is the correct folder. Awesome. So we select the downloaded ZIP file and open it. Here we can like double check if the parameters are correct. So ABC and the angles, and also very important, the space group. Since everything is fine, we just press OK and directly save it. This time I will call it directly lithium silicon sulfide. And also this one should now be available in the folder. And it is. Perfect. And before starting the refinement, and by this we will also uh, end up the first tutorial video, we have also to modify a little the PCR file. Some modifications are important and actually necessary, and some of them, just like this, to give it a title, are unnecessary, but nice to have. So let's call it like the material, lithium silicon sulfide. And a major thing and an important thing is here to select optimized calculation. And then we go on with the pattern. In the future, or in another video, I will show you how to add in second, third, fourth, whatever phase to also refine and figure out the amount of, for instance, impurities. But at the moment, it is not urgent because this is more like an introduction video. That's why we just modify or continue to modify the PCR file. Therefore, we are now choosing the data file peak shape. And this is actually the confirmation that the DAT file has to be in the same folder as the PCR file because it's directly selecting it. You not even have to browse it. If you take the file out on your, I don't know, screen out of the folder, the software will not manage I mean, it will find it, but it will not accept it. And then if you start the refinement, an error will appear. That's why do yourself a favor and keep everything in one folder. Here is everything already correct. So we go on to the next refinement simulation screen, window, whatever. And here we have to select X-ray because obviously we are doing X-ray refinement or XRD refinement. And this is actually one reason why I was showing you the materials project database webpage. The difference in the X-ray source really makes a huge difference in the refinement. You will never achieve a good refinement, maybe even after a certain time the software will collapse if you choose the wrong X-ray source, because with the X-ray source you also change the energy level. As you can see here, it's completely wrong. It's circa the half in case of molybdenum and copper. So we remain with copper. And then we go on with the pattern calculation peak shape. And this is also something very urgent to change. We are not working with this Thomson, Cox, Hastings, something. We select here the pseudo void. To theta is correct. The range, it's up to you. You can directly change it. I never do that. It's optional. That's why at this point, in my opinion, it's not necessary or even urgent to change it. That's why we keep it like this. Background. This is also one reason why I will show you the refinement of an amorphous and crystalline phase. In an amorphous phase, I recommend to choose or select here the 12 coefficient Fourier-Casson series because in an amorphous phase, it's very hard to distinguish and select the background by yourself. So in that case, we trust the software to do a better job than the human eye. In case of the crystalline material, I will show you that linear interpolation is the better choice. Anyways, we take this and confirm it. Exclusion range, same as before with the range, you can exclude some regions. If necessary, I would say it's something you should do in the end. That's why this we can skip. And now we continue with the phase. The name of the phase, and I still don't know why it's not automatically included because it's mentioned in the ZIF file. In our case, it's orthorhombic. And that's actually it on this side. So we can continue with the contribution of the patterns. And here we have again to select X-ray and the peak shape. We are not doing the refinement with a Gaussian calculation. We choose again, like before, the pseudo void. And here we select the use of special control of parameters because it's making our refinement easier and I guess also faster. And then we can confirm. Symmetry. And this is something awesome. If you have a ZIF file, everything here is directly selected. You can also do it manually and ask to generate all the symmetry operation parameters then automatically, but since it's not necessary in that case, we just confirm it and then we can continue. Last but not least, we now actually already so close to start our refinement, and that's why we go to refinement section. Here we have first of all to choose a cycle number of the refinement. In the very beginning, I recommend something between 20 and 30. I choose 30. What does it mean? In the very beginning, you have a high chance to receive an error. So if you overtreat the software with too many refinements, it will collapse. And if you choose, I don't know, a cycle number of 100, then over 100 cycles, the software will try to go through the refinement. And then you just waste time for a nonsense result, or even worse, the PCR file will collapse. That's why in the beginning, as I said, 20 to 30, that's quite okay. You don't waste too much time and the refinement will work properly. One more advantage of having a zip file is listed here. You have directly all the parameters of the atoms. Even the number of atoms is already available. Otherwise, you you had to write this by hand, one by one. And this is actually it. From time to time, it's also smart to save your progress. And actually, we are already ready to run the refinement. But since we didn't select any parameters for a refinement, the plot itself will be awful. Anyways, I would like to show it to you because there is also one special feature which I also don't get why it's the case. Every time the software is asking you to confirm the data file. So you have all the time to select it, and here it's up to you. You can select it and go to open. I prefer just to double click it. And then we have already our refinement screen, and this is how our very first pattern looks like. It's actually pretty bad. Anyways, I would like to introduce you already at this point the important factors which you have to consider and to understand if your refinement is getting better or worse. The first one is the RF factor, so the refinement factor, which is 105, and the chi-square factor. Um, During the refinement itself, I will tell you what they actually mean, but at this point, I just say you try to keep a lowest number as possible. Lower than 2 would be great for the error factor, um, the chi factor as well, but not urgently, and vice versa, because it also always depends on the pattern. That means also on the quality of your measurement. But this is something I will introduce and show you during further tutorial videos. One last thing which we can do just to officially start the refinement is we just remember here the chi-square factor is 992. We go and exit, and this is also something strange that the software every time wants like a confirmation that you want to reload the used PCR file. So we select yes and go back to the refinement. And the very first thing which we have to refine is the scale between the calculated pattern and the observed pattern. It will be not perfect, but already better, like I would like to show you here. Let's save the progress and run the refinement. And as you can see, it's already circa 3 times better. By this, thank you for listening and see you in the next tutorial.